Today I am going to present how to do the analysis of frame without lateral sway by Kanis method. You know what is sway and non-sway. Already we have discussed in different methods. Analysis of frame without lateral sway or without lateral translation of joints. If there is no sway in the frame, the analysis procedure is exactly the same as that of continuous beam, except there may be more than two members meeting at the joint in the frame. While calculating rotation factors, a rotation contribution, all the entire members meeting at the joint should be considered. So you know that at the joint, if there are two members meeting at the joint, you have to find out the rotational moment as per the rotational factor. As per rotation factor, you have to find out the rotation moment. So already you have discussed this is how to find out the final moment MAB and MBA by the superposition of the three moments. That this MAB, the final moment MAB and MBA, that you can find out by superposing the piston moment and the near end rotation moment and the far end rotation moment. So the MAB that you can find out, MAB is equal to MFAB plus twice M dash AB plus M dash BA. Similarly, MBA you can find out MFBA plus twice M dash BA plus M dash AB. The moments M dash AB and M dash BA are called the rotation contribution, or this is called the rotation moments. The final moment is equal to piston moment plus twice the rotation contribution of near end plus rotation contribution of far end. So using this formula, you can find out the final moment. Next, coming to the rotation moment and rotation factor. So the rotation moment that you can denote by M dash AB, M dash BA. M dash AB is equal to minus of KB divided by summation of KB into MFA plus summation of M dash BA. Summation of M dash BA is the sum of the far end rotation moment. This is sum of the far end rotation moment, and this is the near end rotation moment. The near end rotation moment that you can find out by taking this formula. So minus of KB, summation of KB, this is equal to UAB. You can denote by UAB. So this is rotation factor. So the rotation factor UAB is equal to minus of KB divided by summation of KB. So this is the formula for the rotation factor. So M dash AB is equal to UAB into MFA plus summation of M dash BA. So you know what is the rotation factor of all the members. Then you can find out the rotation moment. You can find out the near end rotation moment if you know the piston moment of the joint plus the sum of the far end rotation moment. This is sum of the far end rotation moment, but initially you have to assume the far end rotation moment is equal to 0. At the fixed end, the rotational moment is your 0, but at the other end, you have to assume the far end rotational moment is equal to 0. Then you can find out the near end rotation moment, M dash AB. And you have to assume M dash BA is your 0 in first cycle. And this is the rotation factor. So the rotation factor that you can find out after getting the relative stiffness of the member and the relative stiffness of the joint, then you can find out what is the rotation factor. So KB, this is the relative stiffness of the member, and the summation of KB, this is the relative stiffness of the joint. So relative stiffness of the member divided by relative stiffness of the joint into minus half. So this is the rotation factor. Then these are the steps you know already. So the first step that you have to find out the piston moments. Then the second step that you have to find out the relative stiffness of the members. Then find out the relative stiffness of the joints. Then find out the rotation factors. So these three you have to find out in tabular form. The relative stiffness of the members, then the relative stiffness of the joints, then rotation factor. That three you can find out in a tabular form. Then you can find out the rotational moments by iterative process. After getting the rotation factor and the piston moments, then you can find out what is the rotational moment by iterative process. So this is the formula. You can find out the rotational moment. M dash AB is equal to UAB MFA plus summation of M dash BA, and UAB is equal to minus of KB by summation of KB. Then after getting the rotational moment, then after getting the similar values in two consecutive cycle, then you can stop the rotational moment. Then you can find out what is the final moment. Last value in last cycle, you have to take the rotational moment for calculation of the final moment. So the final moment that you can determine using this formula, MAB is equal to MFAB plus twice M dash AB plus M dash BA. Similarly, MBA is equal to MFBA plus twice M dash BA plus M dash AB. So this is the formula. By using this formula, you can find out the final moment. Then coming to one example, determine the end moment of the members. The relative values of I are indicated on the figure. So this is one simple frame, and here the vertical member length is given 3 meter and the horizontal member length is given 6 meter. And the moment of inertia for AB is I is equal to 1, and the CD I is equal to 1, and the BC I is equal to 3. ABCD, the frame is your ABCD. A and D is fixed. So due to symmetry of frame and loading, the frame does not undergo lateral translation. So here you see due to the symmetrical loading and symmetrical geometry, the sway of the frame not takes place. So due to symmetry of frame and loading, the frame does not undergo lateral translation. So you have to do the analysis of this as you have done in the continuous beam. So what is the first step? The first step that you have to find out the piston moments. After opening this ABCD, so that will like a continuous beam. That will like a continuous beam. So you have to A and D is fixed and D and D is fixed. B and C is simply supported. But on the AB span, there is no loading, and on the CD span, there is no loading. So the load is present on the span BC. UTL load is present on the span BC, and that is 40 kilonewton by meter. So you have to find out what is the piston moment, MFAB, MFBA, MFBC, MFCB, MFCD, and MFDC. Piston moments MFAB, MFBA is equal to 0 as there is no loading on the span AB. Then MFBC is equal to minus WL square by 12. This is equal to minus 120 kilonewton meter, and MFCB is equal to plus WL square by 12. This is equal to plus 120 kilonewton meter. And MFCD and MFDC is also 0 because there is no loading. MFCD is equal to MFDC is equal to 0. So this is the piston moments. Then you have to find out the piston moments are joints. So here you see joint B and joint C. So at joint B, how many members meet? BA and BC. And at joint C, how many members meet? CB and CD. So you have to find out what is the piston moment of joint B and what is the piston moment of joint C. So MFB is equal to MFBA plus MFBC. The sum of the piston moment at B is equal to MFB is equal to MFBA plus MFBC. MFBA you got here 0 and MFBC minus 120. So 0 minus 120 is equal to minus 120 kilonewton meter. So this is the sum of the piston moment at joint B. Similarly, find out the sum of piston moment at joint C. MFC is equal to MFCB plus MFCD. MFCB you know here 120 and MFCD you know 0. 120 plus 0 is equal to 120 kilonewton meter. So this is the piston moment at joint B and C. Then find out the rotation factors. So the rotation factor that you can find out by using this type of tabular form. So first you write the joint, then you write member, then you write relative stiffness of the member, then you write the relative stiffness of the joint, then write the rotation factor. The first column is your joint, second column member, third column relative stiffness of the member, then fourth column relative stiffness of the joint, then fifth column is your rotation factor. So for joint, there are two joints. One joint is your B and another joint is C. This is one joint and this is another joint, B and C. So here you write B and C. At joint B, how many members meet? BA and BC. And at joint C, how many members meet? CB and CD. First you find out what is the relative stiffness of the member BA and what is the relative stiffness of the member BC. You know that is what is the moment of inertia and what is the length of the member. So accordingly you have to find out the relative stiffness of the members. BA I by 3 and BC 3I by 6. This is the relative stiffness of the member BA and BC. Similarly, at joint C, two members meet, CB and CD. So what is the relative stiffness of the member CB? So this is 3I by 6. And the CD, the relative stiffness is I by 3. Then after getting the relative stiffness of the members, then you have to find out the relative stiffness of the joint B and joint C. So the relative stiffness of the joint B that you can find out by adding the relative stiffness of the member which is meeting at the joint B. So here at the joint B, there are two members meet, B and BC. So you have to find out KB is equal to KBA plus KBC. KBA is equal to I by 3 and KBC is equal to 3I by 6. So I by 3 plus 3I by 6 is equal to 5I by 6. Similarly, at joint C, two members meet, CB and CD. So the relative stiffness of the joint C is equal to KC is equal to KCB plus KCD is equal to 3I by 6 plus I by 3. So this is equal to 5I by 6. So this is the relative stiffness of the joint A. This is the relative stiffness of the joint C. Then after getting the relative stiffness of the joint, then you can find out the rotation factor. The rotation factor is equal to minus half the relative stiffness of the member divided by the relative stiffness of the joint. So here you see UBA, this value here UBA. So UBA is equal to minus half into I by 3 divided by 5I by 6. So is equal to minus 1 by 5. Similarly, UBC is equal to minus half KBC divided by KB. So KBC is equal to 3I by 6 and KB is equal to 5I by 6. So UBC is equal to minus half into 3I by 6 divided by 5I by 6. This is equal to minus 3 by 10. So this is UBC. So always you have to check at the joint, the sum of the rotation factors should be minus half. That is UBA plus UBC is equal to minus half. Whether you are getting the sum of the rotation factors is minus half or not, that you have to check here. Minus 1 by 5, minus 3 by 10. So this is equal to minus 1 by 2. Similarly, find out UCB. UCB is equal to KCB minus half KCB divided by KC. So this is KCB and this is KC. So UCB is equal to minus half into 3I by 6 divided by 5I by 6. So this is equal to minus 3 by 10. Similarly, find out UCD. UCD is equal to minus half into KCD divided by KC. So UCD is equal to minus half into I by 3 divided by 5I by 6. So this is equal to minus 1 by 5. So these are the rotation factor so that you got for BA, BC, CB and CD. Then find out the rotation moments. First you go for the first cycle. The rotation moment can be determined by iteration process. So first you go to joint B. First you go to joint B. This is the joint B and this is the joint C and this is A and D. So you have to draw at a joint this type of block. So at a joint B, you have to draw this type of rectangular block. There are two rectangular block, one small rectangular block, one large rectangular block, and the corner you can join this manner. So this type of block you have to do at joints B and joint C. And just in the inner rectangular block, you have to write the piston moment of the joint B. So what you got for joint B, the piston moment that you have to write in the inner rectangular block. Similarly, what you got the piston moment of the joint C that you write in the inner rectangular block. This is here. Then you draw, this is vertical line, this is another vertical line, and this is horizontal line. And that joint, this type of rectangular block you have to make. And here this end is your fixed, end is your fixed, and D end is fixed. Just above this line, above the horizontal line, so you know what is the piston moment, MFBC and MFCB. You got here MFBC and MFCB. MFBC is equal to minus 120 and MFCB is your plus 120. Just write above the horizontal line. Above this horizontal line, you write the MFBC minus 120 and MFCB plus 120. And here the piston moment is your 0, and here also the piston moment 0 in vertical member, and here also the piston moment 0, and here also the piston moment 0. These are the piston moments. Then you got the rotation factor. Here you got the rotation factor minus UBA is your minus 1 by 5. Minus 1 by 5 is your equal to 0.2. UBA. This is BA. So here you write here this trapezoidal block. This trapezoidal block you write minus 0.2, and UPC here you write UPC here you write minus 0.3. Then UCB here you write UCB minus 0.3, and UCD here you write UCD. The corresponding box you write the rotation factor. So these are the rotation factor, and this is the piston moment of the end of the member, and this is the piston moment of the joint, and these are the piston moment of the end of the member. Then just below this one, here you write the rotation moment, and here also you write the rotation moment for vertical member, and for this vertical member write here the rotation moment. First to start the first cycle, and you go to the joint B. First to start from the joint B. When you are taking the joint B, what is the formula? You have to find out M dash BA and M dash BC. You have to find out the near end rotation moment. You have to find out the near end rotation moment, M dash BA this one, and M dash BC this one. These two you have to find out. So at the first cycle, what you have to do? The far end rotation moment you have to assume 0, because this side you don't know the rotation moment. So this side you have to assume 0, and here this side is your piston. So this side the rotation moment is your 0. At the piston, the rotation moment is your 0, and at the other end, the rotation moment is your, you have to assume this is 0. So this side you have to assume 0, and this side is your 0. And you know what is the piston moment of the joint B, and you know what is the rotation factor. Then you can find out what is the near end rotation moment. You have to find out M dash BA. You have to find out M dash AB is your 0. M dash AB the rotation moment of far end of member meeting at joint, and MF is the sum of piston moment at B minus 120 kilonewton meter. We know M dash AB is equal to 0 as end A is your fixed. Already I explained. And M dash CB is 0, assume. You have to assume M dash CB is your 0. Here this is CB. So here the rotation moment is your 0, the far end rotation moment is your 0, and this end is your fixed, and here the rotation moment is your 0. M dash AB 0 and M dash CB 0. Then this is the formula, M dash BA is equal to UBA into MFB plus summation of M dash AB. This is the sum of the far end rotation moment. Similarly, M dash BC is equal to UBC into MFB plus sum of the far end rotation moment, M dash AB. So M dash BA that you can find out, UBA you know minus 0.2, UBA this is minus 0.2. And what is the piston moment of the joint B? Minus 120. Minus 120, and this is the far end rotation moment 0, 0. This is 0, and this is also 0. 0 plus 0. So this is equal to 24 kilonewton meter. So just to put here the near end rotation moment 24 kilonewton meter. Similarly, find out that M dash BC. M dash BC is equal to UBC into MFB plus summation of M dash AB. So M dash BC is equal to UBC. Here this is minus 0.3. Minus 0.3 into minus 120 plus 0 plus 0. So this is equal to plus 36 kilonewton meter. This one. Here you put the near end rotation moment. at joint B you got M dash BA and M dash BC. Then you go to joint C. Similarly, at joint C, you have to find out the near end rotational moment M dash CB and M dash CD. You have to find out this one and this one. These two have to find out the near end rotational moment. So here also what you have to do? So this side is your fixed. So here the rotational moment is 0. The far end rotational moment is your 0. And this side you have to take the far end rotational moment is your 36. Because already you got at joint B, what is the near end rotational moment? 36. But when we are considering the joint C, so the near end rotational moment of joint B, that you have to take the far end rotational moment for joint C. This is, you have to take the far end rotation moment for joint C. So this is your 36 and this side is your 0. So 36 and the 0. 0. And what is the piston moment of joint C? 120. And you know the rotation factor UCP and UCD. Then you can find out the near end rotational moment M dash CB and M dash CD. This is M dash CB and this is M dash CD. This is joint C. M dash CB is equal to UCB into MFC plus summation of M dash BC. So UCB you know minus 0.3 and MFC 120 and summation of M dash BC. This side you have to take the rotational moment 0 and this side you take, this is 36. 0 plus 36, this is equal to minus 46.8 kilonewton meter. So here this is the value, minus 46.8 kilonewton meter, the near end rotational moment. Similarly, find out what is the near end rotational moment here. M dash CD. M dash CD is equal to UCD into MFC plus summation of M dash BC. This is far end rotational moment. So UCD is your minus 0.2 and MFC 120 plus 36 plus 0. So this is equal to minus 31.20 kilonewton meter. This is minus 31.20 kilonewton meter. Now you got in first cycle the near end rotational moment. Then you go for the second cycle and find out the rotational moment. This value, the second cycle value, find out. Second cycle, again you go to the joint B and find out this value and this value. Then you go to the joint C and find out this value and this value. So first you go to the joint B, M dash BA, but here what you have to do in second cycle, so you have to take the far end rotational moment at the fixed end is your 0 when you are going for joint B. So this side the rotational moment is 0, but this side you have to take minus 46.8. In first cycle you have taken this is 0, but in second cycle already you know this value, minus 46.8. So you have to take minus 46.8 and this side is 0. And the rotation factor minus 0.2 and the fixed end moment of joint B minus 120. So M dash BA is equal to minus 0.2 into minus 120 plus 0 minus 46.8 plus 0 minus 46.8 minus 120 into minus 0.2. So this is equal to 33.36 kilonewton meter. Just to put here 33.36 kilonewton meter. Similarly, find out that M dash BC is equal to UBC into MFB plus the sum of the far end rotation moment. So far end rotation moment, this side is 0 and this side is minus 46.8. So M dash BC is equal to minus 0.3 into minus 120 plus 0 minus 46.8. This one minus 0.3 minus 120 minus 46.8 plus 0. So this is equal to 50.04 kilonewton meter. This is 50.04 kilonewton meter. Then you go to the joint C. So at joint C, find out this value and this value. When you will find out this value, the near end rotational moment at joint C, M dash CB and M dash CD. So here you have to take the far end rotational moment. What you got at the joint B, the near end rotational moment in second cycle, that you have to take the rotational moment, the far end rotational moment for joint C. For joint C, that you have to take 50.0 for one side, this side, and this side is your 0. So find out M dash CB is equal to minus 0.3 into 120 plus 0 plus 50.04. This one. M dash CB is equal to minus 0.3, 120 plus 50.04 plus 0. So this is equal to minus 51.01 kilonewton meter. Then you put here minus 51.01 kilonewton meter. Similarly, find out M dash CD. M dash CD is equal to UCD into MFC plus the sum of the far end rotation moment. So this is equal to M dash CD is equal to minus 0.2 into 120 plus 50.04 plus 0. 120 plus 50.04 plus 0. So this is equal to minus 34 kilonewton meter. So this is minus 34 kilonewton meter. The second value you got in second cycle. Again you go for the third cycle and go to the joint B and find out the third value. Then you find out the third value. M dash BA this one and M dash BC this one. Then go to the joint C and find out the third value. M dash CB is equal to minus 51.39 and M dash CD is equal to minus 34.26 in third cycle. In third cycle, joint B, M dash BA is equal to minus 0.2 into minus 120 plus 0 minus 51.01 is equal to 34.20 kilonewton meter, and M dash BC is equal to minus 0.3 minus 120 plus 0 minus 51.01 is equal to plus 51.30 kilonewton meter. Just you put here 34.2 and this is plus 51.3 and go to the joint C, and joint C find out M dash CP and M dash CD. M dash CP is equal to minus 0.3, 120 plus 51.30 plus 0 is equal to minus 51.39 kilonewton meter, and M dash CD is equal to minus 0.2, 120 plus 51.30 plus 0 minus 34.26 kilonewton meter. This is in third cycle. This is M dash CB and this is M dash CD. Again you go for the fourth cycle. In fourth cycle, this is the value 34.28 M dash BA and M dash BC is 51.42 and M dash CB minus 51.43 and M dash CD minus 34.28. Then you compare these two. So in third cycle you got 34.2 and fourth cycle 34.28, and here 51.30, 51.42 and minus 51.39 minus 51.43, and here minus 34.26 minus 34.28. So there is some little difference. Again you go for the next cycle, fifth cycle. So in fifth cycle you got here the value M dash BA is equal to 34.29 and M dash BC is equal to plus 51.43 and M dash CB is equal to minus 51.43 and M dash CD is equal to minus 34.29. So here you compare the fourth and fifth cycle. So there is very small difference. Very small difference, 34.28, 34.29, and here 51.42, 51.43, and here minus 51.43, minus 51.43, there is no difference, and here also very little difference. Then you stop the iteration process. The last value, you have to take the rotation moment. So M dash BA is equal to 34.29 and M dash BC is equal to 51.43 and M dash CB is equal to minus 51.43 and M dash CD is equal to minus 34.29. So this value you have to take as the rotation moment. Then after getting this rotation moment, then you can find out the final moment. So this is the formula. So you have to find out MAB is equal to MFAB plus twice of M dash AB plus M dash BA. MFAB 0, MFBA 0, you know already here. MFAB 0, MFBA 0, and MFCD 0, MFDC 0. Only you got MFBC and MFCB. This is the piston moment. So you have to take this piston moment. And the rotation moment M dash AB 0 due to piston, and here also the rotation moment M dash DC 0 due to piston. And you know M dash BA is equal to 34.29 and M dash BC is equal to 51.43, M dash CB is equal to minus 51.43, M dash CD is equal to minus 34.29, and M dash AB 0 and M dash DC 0. Here you find out MAB is equal to MFAB plus twice M dash AB plus M dash BA. Twice of near end rotation moment plus once far end rotation moment. MAB is equal to 0 plus 34.29 is equal to 34.29 kilonewton meter. Similarly, MBA is equal to MFBA plus twice M dash BA plus M dash AB. MBA is equal to MFBA 0 plus twice of M dash BA twice into 34.29 plus M dash AB 0. This is equal to 68.58 kilonewton meter. Then MBC, MFBC plus twice M dash BC plus M dash CB. MBC is equal to minus 120 plus twice into 51.43 minus 51.43 is equal to minus 68.57 kilonewton meter. Then MCB is equal to MFCB plus twice M dash CB plus M dash BC. MCB is equal to 120 plus twice into minus 51.43 plus 51.43. So this is equal to plus 68.57 kilonewton meter. Then MCD is equal to MFCD plus twice M dash CD plus M dash DC. So MCD is equal to 0 plus 2 into minus 34.29 plus 0. So this is equal to minus 68.58 kilonewton meter. Then MDC is equal to MFDC plus twice M dash DC plus M dash CD. This is equal to MDC is equal to 0 plus 0 minus 34.29 is equal to minus 34.29 kilonewton meter. So these are the final moment. You can also find out using this type of tabular form, because this is the here this is the piston moment and this is the near end rotation moment 0 and this is the far end rotation moment, and you have to take the summation of these three 34.29, and here this is the piston moment and this is the near end rotation moment. This is the near end rotation moment and the far end rotation moment is your 0, 68.58. Similarly for this one MBC, so this is the piston moment and the near end rotation moment this one, and this is the far end rotation moment, and you have to take the summation minus 68.57, and here also this is the piston moment and twice the near end rotation moment plus 1 the far end rotation moment, then this is also 68.57, and here also this is piston moment twice near end rotation moment and far end rotation moment 0, this is minus 68.58, and here also this is piston moment near end rotation moment far end rotation moment minus 34.29. But here you have to take this is the same value, because at the joint B the sum of the moment should be 0. If this is due to the calculation error, here you got 68.58, 68.57, but these two is your should be same. So you have to take either 68.57 or 68.58. This is you have to take here. This is the direction of the moment. Here 34.29 positive, so you give the direction clockwise, and here this is also positive, give the direction clockwise, and here this is negative, give the direction anti-clockwise, and here this is positive, give the direction clockwise, and here this is negative, give the direction anti-clockwise. 68.58. I am taking here 68.58. Both are taking 68.58. Then here minus 34.29. So this is anti-clockwise. Anti-clockwise 34.29. So this is the direction of the moment. Then you have to draw the bending moment diagram. This is in inner side. You take this is 34.29, and this is outside 68.58. Here you take 68.58, and this side also you take 68.58, and here you take this is 68.58, and this side 68.58, and this side 34.29. Then join these lines. Then you join these lines. So this is the bending moment diagram due to the support moment. Then by considering the external loading, you have to draw the free bending moment diagram. There is having the UTL on the span BC. So what is the free BMT? W L square by 8. W is equal to 40 kilonewton by meter, and L is equal to 6 meter. 40 into 6 square by 8. So you will get the value 180 kilonewton meter. The maximum ordinate of the positive bending moment diagram 180 kilonewton meter. at the midpoint, and this is parabolic. The positive bending moment diagram is your parabolic. Then this portion is your cancel each other. This portion cancel each other due to positive negative. So the remaining portion, this is negative, this is positive, this is negative, this is negative, and the inner side tension you have to take positive. Here this is positive, and this is also positive, and this is negative. So this is the final bending moment diagram of the non-sway frame. Now all are clear that how to solve the non-sway frame by Kanis method.